All right, we're now live. So today we're looking at the hardware intrinsics. Last week we looked at the ARM ones, and this time we looked at the Intel ones. So you prepared a deck very helpfully. Let me first fix the layout here because that makes our life a little bit easier. All right, we're now live, and I should probably turn off the audio. Today we're looking at the. Never had that problem ever before. All right, so.
Okay, first of all, I would like to go over the current implemented status of the Intel hardware intrinsic project in .NET Core. That some people may not familiar with the progress.
Right.
And then I classified the API issues that we want to talk about today to the several categories. And I think the first three items are more important that may block our following work. And I think we can go ahead to the next page. Okay. And we know after we propose the API, we already implement most of the intrinsic and infrastructure work in the runtime and JIT for .NET Core 2.1, and that implements all the SSE to AVX and most of the AVX too. And currently we implement more ISA classes and just a few guys remaining now, and I think that will be finished soon. And the remaining work is the tribute guys are just to enable a few remaining AVX2 and BMI intrinsic and all the SSE 4.2 stream processing intrinsic. But for that one, we needed to redesign the APIs that we talked, and that will be addressed today, I think. Yeah. And maybe some more intrinsic that's required by the community.
And to be clear, like .NET Core 2.1 implements means it's in the JIT, but we didn't expose it, but we didn't ship a public API. We only had a NuGet package.
We implemented it in the JIT and exposed.
Exposed as in system runtime intrinsics experimental.
As a preview feature.
Yep. That's what I remember. Okay.
Yeah. That's good. Okay. The first one is to improve the SSE 4.2 stream processing intrinsic APIs. Okay. For the first two items, I think we already get the conclusion that we can make the suffix of the implicit learners and the explicit learners, and instead that we can handle it by the overload. Even though it can complicate the JIT implementation, but we plan to hold it in the runtime rather than the API. And then we eliminate one more constant parameters, because usually we see that for the IMM intrinsic that takes the compile time constant, that parameters only have one constant parameter. Yeah, that will be much easier to implement and more stable on the runtime. So here is an example that previously we designed the compile implicit learners here, and now we just have the below one. That's we can see that we encoded the result flag into the function name that for this one that's corresponding to the path match. Yeah, but
so did the APIs ship this compare implicit length? Did it ship in .NET framework?
No, these are all
not experimental.
It didn't ship in either.
Oh, okay.
Yeah, this is one of the APIs where, unlike most of the other instructions, it's a very complex. There's 4 instructions that actually perform like 30 different functions total. So the instructions are a bit overloaded, and we need to have a good API design for how we expose it and break it apart into multiple methods.
Right.
Because the way it works is you've got 4 instructions, and each one takes in the mode, which says here's the comparison type I'm doing, and then there's one of 5 different flags it can return, depending on the instruction for different state checks you can have.
Right.
So the end result will be, we won't be shipping the first signature. We will only be shipping several of the second ones. Okay, good.
Yeah, and then the remaining topic, I think, is the design of the new compare mode is compile time constant parameters. And okay, the problem here is that okay, here is the example of it. Some of the value has different thematic on different contexts, and some discussion worry about that is not very type safe on this intrinsic. For example, we can use the most significant in this value in a intrinsic, but that doesn't need it. That actually needed a unit mask, but actually that works. Okay, because we know in the instruction level, hardware instruction level, that doesn't have this kind of type. That's just care about the value. So right now we just recommend to keep this current design to keep the API close to the C++ intrinsic and the hardware instructions. But if we want more type safety, then maybe we need to explore this type to several.
Do you have a list of all the modes that you expose? Like how pervasive is the problem? Like, is it just 2 items, or is it like 20 items, or?
Yeah, we have it in the API.
Because I think that depends, right? If you already broke it apart into several methods, and if, let's say, method group 1 only uses, 5 of them, and the other one only uses the other 5 of them, then maybe it's worthwhile splitting this into multiple different types.
Oh, so the way we've done it for the other APIs, so effectively the string comparison mode is an immediate value. It has to be a constant for the instruction to be emitted. And for most of the other instructions, they don't have like named values per se. So we've just had to take a byte and then interpret it directly. This is one of the cases where on the native end, they provide several defines for well-known values. But the native signature still takes a byte.
So if it has to be an immediate, what's the behavior if someone calls it with a variable?
We emit a fallback with a switch case and throw PNSE if it's a non-supported constant.
Okay.
So, but from the existing ones, how many of them are logically bit masks anyway, where you basically encode, permutations, for example, where it always has to be effectively an int, versus cases like here, where you basically say, well, it's a number, but realistically, there's like 6 or 7 different specific bits that mean specific things.
The only other instruction, and maybe correct, is the comparison instructions, which for the 128-bit versions on SSE and SEC2, we just broke them out because there's only 4 or 5 compare states, so they're actual explicit methods. But for the 256-bit extensions, there's 32 different comparisons, and we have an enum for that.
But that's a simple enum, isn't it? Like, choose between A, B, and C, right? Versus this one is, choose between A, B, and C, but, B and C are the same thing depending on which method you're calling.
Yeah.
So you see, like, there's a question posed here. So should string comparison mode be type safe or close to the hardware intrinsic behavior? And my intuition tells me we are either doing intrinsics or we are doing good APIs. I kind of don't like the in the middle, which, like, if we have opportunity to do intrinsics because they kind of make sense, they are simple to understand, we just do it. And we say they are intrinsics. Otherwise, I think we should switch to the mode where we are just designing, potentially, APIs that potentially take advantage of some hardware features. Where, like, if we kind of keep it like I understand you proposing.
Okay.
It's kind of like in the middle. It's neither
Yeah.
really intrinsic, nor it's how we would design API, .NET API, because there are like values in the enum that you have to know which ones you can pass where.
Would you go that far though? I mean, like, it's not that they have like, crazy implementation, right? Like, it's literally just, I take a byte, and it would be very ugly if you have to know that byte number 6 means this and byte number 5 means that.
I mean, you can have constants for those.
Yeah, that seems like a
C route.
reasonable.
Just expose the constants. People figure out which ones they should order together, when they should order them together.
You can even call it the same, like just static class or something with a couple of constants.
Well, why not just have an enum then? Because then that's a typed constant. And then because
it's weird if you have two things that have the same value and mean different things, but only one of the two values is going to be interpreted in a given context.
But is that
Well, actually, no. Either one. If you just pass, like the name implies that this value is invalid for some operations, but you can just pass it because you don't look at it disappears. Just
So
the number is being passed.
I just think it would be weird if I'm writing the code and there's an enum and it tells me that I'm doing a thing like, most significant. That sounds relevant, except in this particular instruction, it's.
I think the
So I think the enum is leading me astray.
But it's what I'm saying. It's even worse. You can pass most significant, and it will exactly do what you
it'll do
wanted.
It'll do whatever.
Except it will be
whatever
completely
unit mask
bogus
Yeah.
when you read the code.
right.
But that's a case where analyzers could help. And it's also the case where you could do the same thing with a constant. And if you're working with hardware intrinsics, you're supposed to be familiar with the API anyway.
Yeah, but so again, I think that in this case, the enum is leading. The existence of the enum will lead someone astray, and so I would prefer it just as consts, personally. Or if the usages are always non-overlapping, then split it into two enums.
Okay, but I
And
don't
make it
understand
clear.
how constants will help you because you have, let's say, public static class, string comparison
The
mode.
constants don't help you. Therefore, you have to know what you're doing.
Well, but I'm not sure what you're proposing now. Like, are you saying that
No, because
you should just have a static class with fields that are const? Because that's effectively what this enum is as well. Or are you saying don't have anything, literally just type in the value?
Well, no, I think there's a difference. I don't know whether I'm on which side of the debate I am, but there's a difference. When you use an enum, IntelliSense will show you options, and it kind of implies that you can use any of these options.
and also
When you
implies
have
that
a static
any-
class with
yeah, sorry.
constant fields or properties, fields probably will make them. It kind of there's no implication. IntelliSense doesn't show you a list to choose from.
Well, if you have constant, they're presumably a member of something, right?
Yeah. So
So as soon as you do the IntelliSense dot there,
you're
then
right.
they'll show up.
Actually,
Right?
IntelliSense will show you that.
So they would just be constant values hanging off of intrinsics.sse4.
Right.
SSE4_2 or whatever this is called.
So we already use enum in other places for situations like this. The only reason we are calling this out is because more than one enums in this case map to the same value, right? So that's really the only thing that we are calling out. And it's actually these constants are used by the instructor, right? Encoded in the instruction. So our suggestion is basically keep it as is.
Or maybe have
and-
two overloads, one of which takes enum and the other which takes
Yeah,
byte.
can't we just break this out into two comparison modes since one of the it isn't most significant for
Probably we need
implicit
it.
length, and then unit mask is for the explicit length one.
Finally, probably we need a 3 compare word. Yeah, because there are 2 pair of this situation.
Yeah, and that would having multiple enums so it's clear in this call these are the things that make sense in the call. Like I think that's great when IntelliSense can help you.
Okay.
I think that merging them all into one enum means IntelliSense is hurting you.
Okay.
So why don't you take that action item to see how you can break those down?
Yeah. Okay. Thank you.
Let me click again. That's one, yeah.
Okay. Another one is about how to determine the expose the hardware intrinsic that only support in 64-bit mode. Okay, most of the hardware intrinsic we proposed is SIMD intrinsic. But some of these guys also operate over general purpose registers, and but some of these guys require the 64-bit general purpose. That's REX, RDX, something like this. So this kind of intrinsic cannot work on the 32-bit platforms. And currently, we just throw a platform not support exception when you call the this kind of intrinsic on the 32-bit platform.
Right.
But but this solution has a drawback that okay, we know that it's really straightforward if we use a SSE intrinsic. But before that, we check if SSE is supported.
Right.
But it is maybe not explicit. We also need to check environment is 64-bit.
Right.
Yeah, preciser. And somebody always forgets to check it. So that's maybe a problem. Here I summarized some of these guys, and most of the problem is related to the scalar intrinsics. That's sometimes, for example, the BMI and the leading zero counts, pop count, and the SIMD intrinsic. A few of the SIMD intrinsic has this problem, like the converts from the SIMD to scalar or scalar to SIMD, or the extract or insert a scalar value from or to the vectors. There are also some helper intrinsic, like the set the element value of a vector, but that is a helper intrinsic. We can provide maybe the software fallback for it, because that is the helper intrinsic. We don't need to guarantee the cogen of it. You're right. Okay, but so now I think the problem is mainly about the scalar intrinsic.
So is this that within a given instruction set extension that some of the instructions will work in 32 and some of them only work in 64?
It's like 99% of them work in 32-bit, but there's basically like 5 methods total that don't work in 32-bit. Convert to uint64 is actually a little bit special because it calls moveq, and there is an encoding that works for moveq on 32-bit.
Yeah.
So it's even more confusing than just like if it returns a ulong, it will or won't work, because some of them that return a ulong can work.
I'm just wondering, like, if I know that we're naming the intrinsics based off the ISA, but I wonder if we should split it into, I'm going to assert SSE2, SSE2 underscored 64 or something, and then put these 64-bit only there, so they go back to, you call the is supported, and the is supported for that one will build in the MIF in 32 or 64.
But I think so. It's kind of what we did for ARM, correct? We have 32 and 64, but it's slightly different because it's
those are actually
what
just
chip
different
you
instruction
have.
sets. So.
Yeah, it's differently what chip you have, and this is kind of the mode of the process, which is.
Yeah, and then the other part is we, after the last meeting that we had, which was not, I don't think we publicized it, but MO suggested that we, in order to help solve one of the other problems, we just make the classes abstract but not static, so don't seal them, and then have them inherit from each other. And since there is no multiple inheritance, if you add the 64-bit overloads, then things get weird.
I mean, while I wasn't there, I would be opposed to that because it makes it very awkward of which is supported or you call it. Yeah. Because C# unfortunately lets you call the base classes static members.
Well, right, but the point of it is if you call SSE2 is supported, then SSE is supported will also return true, because that's how the ISA is defined. Yeah.
So if SSE2 dot is supported returns true, SSE dot anything will work.
Yeah, but
aside
it
from
would
64.
also be really easy to forget to add one.
And will these 5 instructions, will it ever change? Is it possible for them to suddenly become supported on 32-bit processors?
Not without a new ISA.
It will compile.
I see. So then we would put the intrinsics into a new class, basically. Is that what you're saying?
Yeah.
Okay.
Yeah, I think so. To me, the problem is it's really about the predictability, right? Like as a developer, what am I supposed to do, right? And the API service kind of implies that you check one thing, and if that returns true, then everything is supported, right? As soon as we add this wrinkle where we say that's true 99% of the time, except when it's not true, it's not really helpful at that point. I mean, maybe an analyzer is the way to do it. Maybe that is good enough if it's really such a low number of things, because it also feels like if we have to split the types, as Tanner said, like I like the inheritance because it removes the, oh my god, I only care about SSE or I only care about AVX, but now I have to like remember which instructions introduced in SSE2 versus SSE3 or whatever, right? Like that's the thing you don't want to deal with. But I think from a practical standpoint, yeah, we cannot do multiple inheritance, and so we can only model like same things, I guess. So if we have outliers in here, then I wonder what the best way of doing that would be.
But is it true what you said, that all the previous intrinsic APIs that we reviewed, if it's supported, returns true, they work?
Yes, that's how we did that. That's why we split the ARM ones in particular, because they were different. And first of all, they were different shifts, but also it's because you don't want to do different checks. Like I think if we could come up with it with a layout of types where that is true, I think that's the best way of doing it.
Well, and then there was a suggestion there of 4 ones which are 64-bit only, just like append, like underscore 64 or 64.
To the method names?
To the method name. That way it's clear that you can call this and it is supported, but on 64-bit only.
Like, while pop count 64-bit makes sense, then convert to uint 64-bit. I mean, I guess if we put in an underscore, you can tell which or where the number stopped. But
you have a 6,464.
Yep.
We have other tools other than inheritance. We could use nested types. We could have a .64 nested type that has just under or something.
We can also say that for the people that don't care, we just recommend that they do static import of the types in the beginning, and then their global namespace has all of the intrinsic methods mapped into it. Like there are language workarounds for the different problems that we
actually I like that idea.
We have a nested type called 64, and they have these members on it, and you can even have it supported on it as well.
Well,
we cannot have a type called 64. It doesn't work with each other.
We can spell it out with words.
But you can only do that once.
64, SIX.
Oh, I see.
So Wes, if SSE2 had one of these and SSE3 had one of these, and SSE3 extends SSE2, you
Well, I mean,
It's
you
not
still
perfect.
you could have an index 64 and have it inherit from the base x64, and then you would just call SSE2.64, and you'd get the SSE ones. Not that there are any SSE ones.
I guess I don't. Do public nested types of derived types use the same name qualifier?
It's
Or
a
is
fully
it-
qualified name. That's how it's differentiated. So,
But you can use a partially qualified name if you're inside the class. I guess it does the
right, but you can't. But all methods in the class don't call anything. So,
Oh man, that one's trippy. All right. So that could work. It seems a little weird that if I'm looking for pop count now, I need to go look inside a nested type.
well, it's only if you want pop count of 64-bit, and if you're on 32-bit, then you have to do like 2 pop counts, 1 for each side. And that's where the general purpose like bit ops.
Okay, so pop count 32 works on 32, and then pop count 64 works
On 64 only, because pop count 64 requires a 64-bit register.
Just to be clear, pop count 32 would work on that.
Well, yeah, sorry, yeah, but there are two. There's the 32-bit mode and the 64-bit mode of pop count. But the 64-bit mode only works on. Yeah. I was reading that as there's only one instruction and it's R registers. But if there are 2 instructions.
Well, it's one instruction,
It's one instruction, right?
but 2 encodings.
Oh, fair enough.
naming convention.
I write C#.
These are all like combination, right? Where naming.
Ones and zeros happen by somebody else. So.
I should say or. All right. I recorded it. We should think about that. I don't think we need to design it here, but something to think about.
Okay, the next one is about a special helper intrinsic that is called a StefanCast. We needed this intrinsic because sometimes that we have a intrinsic that only works on one base type of the vector, but actually we doesn't care about its element type in the underlying hardware instruction, like the shuffle or move. That's just to move the elements, but it doesn't care about the format of it. Okay, and this intrinsic used as in mainly two situations. The first one is that in this kind of shuffle or blend intrinsics, and the other one is that make the non-generic intrinsic work with the generic code. For example, if you want to write a generic type of the vector 256 bits and, but the float and the double is in AVX, and the integer versions are in AVX2. The user can write their own version of the generic one. That's to check the type. Then we can write something like this instead that cast the non-generic type to generic one. And the current problem is that the community feedbacks that sometimes they get too many static cast call invocation in their program. So they want maybe a better design to eliminate this kind of situation. Okay, and can we go forward?
So I think the question there, what did we decide last time? Didn't we say mostly we don't want to expose generics in our code or leave it to the consumer code?
Yeah, so I guess the problem with fully exploding this type is that we've got 10 base types, which may expand in the future, and 10 target types. So you're going to have like at least 80 overloads or however you do that math. And so one of the recommendations was to partially explode it. So basically drop T or U, and explicitly so you would, the generic type would be the return type, and then you would explicitly explode the input type. That way you've got at least less typing you need to do for the conversions. One of the reasons why this is so hard in C# is we made the decision to explicitly differentiate the integer types, whereas in C++ you only have the M128I type, which represents all 8 integer types at once. So anyone using this to work with integers requires significantly more casting than you would in native code.
So is it about casting, or it's about verbosity of the syntax?
The real problem right now is the verbosity of all of the reinterpret casts.
Because they would have to do the exact same in number of casts, correct? It's just the syntax for the cast would be the same.
Yeah, the syntax for the cast right now is overly verbose.
Yeah, can we go?
Yep.
Go.
So what is the do you get, so it's gonna be like you said 80 or 90 overloads if we fully expand it?
If you fully explode.
Is it so bad? Because I kind of feel like if we just expand one side, people looking at the API will be like, why did they just like randomly pick one side and expand it?
Well, and
it's so not like transparent. We try to strive to make APIs such that you look at them and you kind of can guess what the designers were thinking.
Yeah. So the other bit here is that this is the same API that ARM needs, and this falls into the discussion of this is a general purpose helper API for these that maybe we might want to expose on the vector types themselves.
Yep. Probably for the first suggestion here, let's explore the frequently used intrinsic to more base type overload. And yeah, according to the same-day programming experience, maybe there are just some of the intrinsic we needed to explore them to all the base type. For example, here the align right offline variable in AJAX2. In the hardware menu, that says okay, it supports just the 8-bit byte element, but actually we can use it for all the integer types from the thematic perspective, and we can definitely explore it to all the integer types like int, float, ulong, and that would improve the user experience so much. And,
so could we make them into extension methods and use C# inferencing to solve this problem? You know, like basically one of the t's could be inferred.
Well, that's what we were saying by just drop one of the t's and partially explode.
Yes.
If we just explode it to 10, where t is the return type, and then we don't need u.
So, but that's right. So that in this case we cannot randomly choose either t or to expand either t or u. It would have to be the source that is expanded.
Yeah.
Yes.
I see. Is the full, so I mean you said 10 and 10 and then said 80. Is the full matrix not support? Because that,
well, it's like the full matrix.
The destination actually.
well, because I remember one of my reasons for suggesting exploding the generics in the ARM was not like there were holes in the in the story, and it was like, let's make it very clear that there's a hole by just not having that method.
Yeah, and in this case, it will basically all you're doing is a reinterpret cast. So it doesn't care what the type the 128 bits is, as long as it's one of the primitive types that the API supports.
And then the JIT.
The JIT literally today just inserts it inserts a little bit of magic to say, like, drop this call, just treat it as if it was always this type.
But then if it's a type that it doesn't understand, it'll just JIT in a throw.
Yeah, it will say type not supported or whatever.
I mean, I think to me the bigger concern with these explosions is like how bad is it moving forward, right? Like, I mean, if I don't see a world where we would add like 20 more types to that, right? But I mean, 1 more, 2 more is conceivable, right? And then, but it doesn't seem like this would be too bad. I mean, there's still this concern that I don't think we have measured this, like how bad method will be bloated by these things, right? Because I think we said like in aggregate we probably have like a couple thousand methods if we will fully explode everything.
Yeah, and right now the big part of the metadata explosion, like I mentioned last week, is because all the method calls are recursive, so we can't fold multiple method signatures into one.
Right.
But if it was a concern, then conceivably we could change how that was recognized, and that way we could actually fold signatures together to remove float.
I think I've recorded the issue as much as I could. Actually, I have not, as it turns out.
So if we could do the inferencing trick, then I think my objection of just removing 1 or expanding 1 is not valid, because then the explanation is basically only one of those can be inferred, the other one cannot.
Yeah.
Therefore, we leave the one that can be inferred as generic parameter, the other one not.
The type argument inference is available in which version of the C#?
It's available it has been for a very long time. It's just they would have to be static methods. They cannot be instance, like somebody suggested.
Okay, I see.
Yeah, these would have to be static methods, and we have to have the return type as the generic.
But that one can't be inferred.
Yeah, well, you also can't overload based on return type, so return type has to be generic.
Or return type has to be generic.
because you can't overlay based on return type. So
Well, we would have to name the methods like cast to uint 64.
that's just as verbose as cast of t where t is un.
Well, we cannot infer the like.
You can infer the input parameter based on the type being passed in.
We can infer, of course, we can infer the input parameter, so it would be t. It would be generic.
No. You explode that part, and you
well,
have
then you don't infer it. If you explode it, it means it's specified that there is no need for inference.
Well, we wouldn't be able to do this with actual inference because return type inference doesn't exist for C#.
Yeah, that's what I'm saying. The only thing that we can infer is the source. Correct? And then the destination you would have to specify, and it would have to be a suffix in the name.
But how is that any better than just having?
Because typing, angle brackets is hard, and typing in 64 is not. I mean, honestly, like it's not that it's. I get your point. It's not perfect, but it's better. I believe that some people
IntelliSense helps you too, right? Like auto completion will let you pick, as opposed to having to type in 64 or whatever.
Yeah, that's a very good point too. I think people don't like too much generics in their code because it's kind of so busy. You have so many like angle brackets. If they are method names, it's not too bad.
The problem is also when you hover in IntelliSense and you get these generic things because it shows a generic type and it shows the parameters down and it never looks nice. I mean, my other concern with those is like right now if the full matrix is supported, great. So we could do generics. Then we add like, I don't know, a new primitive that it's not everywhere supported, and now we suddenly introduce a P and a Z somewhere where, if you use the wrong type, then bad things happen. Right? If you explode them, you never have the problem. Right?
Yeah. Well. So today the static cast method itself doesn't do any type checking. It just converts it to the target type of the method.
Oh, that's right. So and
then it relies on the method to throw if it's not supported. Which hopefully the C# type system for how we're exposing the methods would catch first.
Because it would basically just allow the
right,
quote unquote primitive types.
Yeah, static cast is literally just there to work around the C# type system for vector 128 of int and uint should be considered identical for most of these methods.
What does it do for misaligned type sizes and misaligned?
It doesn't care about misaligned.
Just random bits at this point.
Yeah, at the point you call static cast, it should already be in a register. So you should have loaded it using load or load aligned or some other method. And you shouldn't have to care about memory at all.
I mean, this is not really an intrinsic in the sense that it does anything, right?
This is a helper method.
Yeah. Right. I think this is one of those things that we have to look at the actual APIs to like see what design we like.
And in fact, the point that you just made is a good point. This will always work. It shouldn't even be in the intrinsic side.
It shouldn't be in the intrinsic?
Shouldn't be. It's a vector operation. It has nothing to do with intrinsics.
Well, it's to operate on the intrinsic types. So this is where last week we discussed things like set all vector. We might want to move to the actual types themselves, in which case you might consider exposing vector 128.cast2 or whatever. We've got a similar method for span, for example.
Right.
Or I guess with unsafe we call it as. So you might consider vector 128.as.
If we want to take advantage of inferencing, they need to be static methods and they cannot be on vectors. Right.
Right.
So is that what we are recommending? It's basically some static class next to vectors.
I mean, we recorded the same issue last time, right? That we said like the two things we should put on the vector types is effectively setting and casting, right? And I think this is the other side of that because last time we talked about initialization and that's the casting side. So I would say, yeah, they're basically hardware independent, right? They're literally just like working around our type system. So they always work. They're independent of whether we add new primitives or not.
Well, so we could do it as methods on the class as well if we call them as single, as double, as uint32.
Or you can actually make them class. Like actual conversions, right? No, actually,
no, I was saying like if you expose a method called like as uint32, then you could just say, vector or left dot as uint32 when you're passing it in, which is very readable. It doesn't require any brackets for generics.
Yeah.
Would be exposed directly on the vector type.
So they would not be extension methods?
No, I was just saying expose an instance method as well. Assuming, Carol, do you think there'd be any issues with recognizing that for an intrinsic?
I wouldn't think so.
Okay.
I mean, if you make them extension methods, they have to be by ref, all of them, right? Because you don't want to copy them. Right?
Well, so they would be as what? Say the whole like.
You would call it as uint32, and because it's a vector type, you would
get back a vector.
You would get a vector of uint32.
Yeah. I see, and it works on all. You can always.
Yeah. So we could just expose the types that are supported. There's 10 today, and then when half comes in.
To be honest, I like the fact that they're on the type, because it also kind of from an API service constrains the type visually to say, yep, T is one of those 15, right? It's not a random T.
Yeah, I would agree. It would be nice to actually be able to look at how it would look.
I think Outlook just crashed on that. All right, so I think I've recorded these two things, and then we should look at how this looks like. Does this capture everything you have here, I believe, right?
I guess the other point is it's the first point there for the methods where the instruction manual says it operates on byte, but where people may want to also operate on it as if it was a uint. Do we just want to expose it as byte and tell them to use the cast, or do we want to expose additional overloads? I would imagine just the cast to keep it simple, and that way it's clear that this is what it actually operates on.
Isn't that what we kind of said last time too? That we don't want to explode all the operations. We would just say, yep, every once in a while you might have to cast because logically the operation makes no sense. Except, what was the example that we had was like this transposing thing here, right? Where it's actually operating on individual bytes, but when you use floating point, it kind of doesn't make sense unless you choose your byte mask accordingly. Right. I mean, those are the kind of things I would say. Yeah, I mean, if you really want to do something crazy, then you have to cast it yourself.
Okay.
Yeah, in my opinion, that some of the intrinsic, like the blend variable, that can have the correct semantic on all the integer type. That in this situation we can export it to the all the. But some situation like in some math library that others want to manually assemble the binary bits with the integer type, then at the last cut it to the float or double vector. That in that situation, that we should handle it by the cast intrinsic.
Alrighty, let me put my cursor again. There we go.
Okay, the next one is about the new intrinsic API request. And
before we go to this one, is the slide that covers the missing APIs, the ones for instructions that aren't exposed, is that next?
That's next page. Okay. And now we know that we already exposed all the SSE to AVX2 that memory, and that there are some new requirements from the community that require most of them about the scalar intrinsics. That's not properly abstracted by current language. here. So the two questions comes from this kind of requirement. We think the first of all is which instruction should be added as part of the intrinsics. That's this requirement just comes one by one, and most of them don't have a formal API proposal. But from our opinion, that we think if C++ already has this hard intrinsic, we probably need to match the C++ side if it doesn't break the C# semantic.
Do you know how C++ chose which intrinsics to add? Like what was their thought process?
We don't, or I don't. And it's not consistent, right, across different compilers. So some intrinsics are supported on some compilers, but not the others.
Yeah.
So it's not consistent among the C++ community themselves either, right?
So why would we use C++ as a?
But you know, C++ intrinsics,
if we know that they are not consistent and we don't know how they chose it.
Have been around for a long time, right? So the thinking is that whatever use case people had, it has been incorporated in those intrinsics.
I think for the most part, for most of the native intrinsics, having looked at the ones that the various compilers expose, there is a core set that is shared between them. And for the most part, they're things that are difficult to do code pattern recognition on. So for example, add with carry. That's difficult to recognize an exact pattern for to get it to emit the add carry instruction. And so most of, or in fact, all of the compilers expose an add carry intrinsic, so you can explicitly say, this is going to do a carry operation, optimize it as such. There's others like divmod, where only one or two of the compilers expose the intrinsic, because that one's generally easier to recognize the pattern for. Just look for a divide and a modulus operator on the same one. But it's something that, like the JIT today doesn't recognize.
So let's say we use C++ as the guide. Would we do a union? You said that different compilers expose different intrinsics. Are we doing union or
no, but I think this goes back to what Tana was saying, is that if there's a large intersection, right? The union is large, right? And then there are these one-offs that are not in that intersection.
So are we doing intersection? Or?
I think this is a case of we should look at the intersection, and as people, see these particular use cases, we should review them and decide whether or not we think they're also applicable to C# and managed.
Are these things that are like I-286 or like I-686?
Most of them are like, most of these up here are ones that have been around since the 8086.
And we require SSE2 up, so
right.
It must be fairly new.
But there's some of them like which may have specific CPU support, like the enhanced repeat move string byte. That one is it's been supported since the first Intel CPU, but on newer CPUs, there's a specific feature that says like this is as fast as a optimized XMM copy for various cases. And there's a CPU ID check for that.
It's available, but if you have the CPU ID, that means that's faster.
Yeah, but the encoded instruction would be the same and would work all the way back.
Right.
Because not really knowing the answer, my guess, like we're saying everything else, it's the name of the ISA that defined it. So if this is something that was defined in 286, and we just make a class I286, and if it was defined in 486, add it to 486, and be very clear. This is when this came in. This is the manual to go look at.
The only argument against it is if I don't know what our minimum requirement is right now for the .NET runtime. If it's something that came out 5 years ago, I would also be okay to say that's our baseline. That's what we call base, and everything that ships after is named after the actual instruction set, right? Because at this point, who cares whether it was 886 or 286? This is like ancient history that you don't run on anymore.
Well, there's
just a question of how.
Yeah.
writing docs and helping people understand what instruction it is they're trying to call.
Right, but I think to me, like if we split it into different types, you like the call to action is you need to check it's supported. But when you know basically for a fact you can never not run on it on a 286.
Well,
like then
you can never
run the CLR on 286 machine.
and it's a pointless thing to do.
There was a person who went and hacked the runtime to run and compile for 16-bit computers. So yes, we can, and people are doing it, even if it's never going to go anywhere.
Right, like, yeah, so...
And that is it's fair.
There's
they would have to be very careful when they call the base.
Yeah, but there's things that we build and we support, and then, like, we are an open source project. There are things that other people build and other people support. And
yeah, I like the idea of collapsing into base some reasonable subset.
Reasonable.
I mean, fair enough. I mean, if there's ever a definition of a 786, we'll need to say the things that came in that new baseline instruction set are not base.
Yeah, I think it's basically anything that was always supported as base and everything else is in a CPU ID check. And so far we've said that anything that's behind a CPU ID check for an actual encoding, we've put it behind a corresponding ISA with an is supported check.
Right.
And I think we should probably just keep that for logical sanity.
I think that's fair. I mean, like,
I have a question about the div mod. Why would we expose an intrinsic instead of just changing how math.divram works?
No, we would do both.
Yeah, we would update.
Why would we do both? You have basically now two APIs that are exactly the same.
Because it generally doesn't scale, right? So the problem. So we had the same conversation on PopCount, right? For some things that we will implement everywhere, the way it should work is the everywhere API literally just has if statements in it that calls the intrinsics.
Not every
That's
CPU may support a combined div mod. So, and you may want to do something different if it doesn't support a combined div mod.
Really? There are CPUs that don't support combined div mod? Which one?
Sorry. Are there Intel architectures / AMD 64 architecture chips?
Not for x86, but there's other
So no one would ever want to call the intrinsic aside from math.divmod.
Unless you were trying to write performant code and you said, on Intel, I want to definitely have the combined one, and everywhere else, I want to do something different, like a...
But if it's going in an instruction set class, an intrinsics class that doesn't have an is supported, that means it is supported. So you could check your processor type.
For base, you would still have is supported, and it would return false on R, for example.
Right.
Fair enough.
I kind of don't care too much because it's one method. I just wanted to see how we think about it. And still, I think that this method will be completely useless if we change how math works.
I mean, aside from making it easier on the
I don't know when I would call.
No, but I mean, the question is how do you implement the math one, right? I think the idea was that those will be the things that we implement the rest over.
It means that we do the JIT work here, and then the JIT understands.
We can do the JIT work in math.divram.
Yeah, but then when you move to mono, does it do the same thing?
Well, same mono has to implement the intrinsic.
Right. But then you actually know, like, I am definitely getting a combined div mod versus I may be getting a combined div mod if the runtime supports it. It's a 100% guarantee versus a
Well, I mean that one I have to be honest, I don't care that much because I would say that is generally true with managed code, right? Like it's always you call a method and it does something, right?
Right.
But I think the question is, I think it's fair to say that some of the intrinsics probably should be general purpose methods because we know they're effectively supported everywhere, and if they're not, at least we have a same software fallback. But the idea was that the intrinsics are the one with the true home, right? So like even if we have the generic one, we would still have.
Are we adding all CPU instructions to the base?
I don't think so.
Well, all the ones that are sane. Right?
What if I want to add and I want to know it's only one instruction?
I think that's different because it's not a combined operation.
Yeah. What? Like a div mod is a combined operation?
A div mod is a single instruction and it returns both the quotient and the remainder.
I know. There are many CPU instructions. Right?
He's basically saying, will we add a method for adding two ints and returning an int? Right?
Well,
like I mean, where do you draw the line? basically.
Well, I think the difference there.
No. Are we adding a method to add to ints and give you some flags that the processor also gives you during the same operation? After
I want the Z flag.
Well, that's what effectively add with carry would do, for example, because you want to do add with carry for efficient big integer implementations, but pattern matching against a add with carry algorithm is hard.
Yeah. Anyway, what I'm saying is that basically math.divrem is literally will have the same signature, correct? Probably. As this intrinsic, and it will always work.
Well, not.
Therefore, we will have two methods that are exactly the same.
Not necessarily, because so the div and idiv instructions, they'll take two integers, or I guess multiply is a better example. It takes two integers and returns a long. Because it returns a 64
I'm
result.
talking about div mod.
Yeah, and
div mod will have the
I believe it has.
Yeah, I think so. The other thing is I don't know how intrinsics work. Like how does the JIT deal with things like math.divrem? Can we map this to different intrinsics per different CPU, or are the APIs always tied to a specific CPU?
So for things in math, it expands them differently for target CPU.
Some operations, but divrem would not. Divrem would always be the same, correct?
On another, for example.
Sorry, say the last part again. You cut off.
Sorry. So some things will be intrinsics on one platform, but not on another.
Right.
Intel, we would always call this guy now, but on ARM32, there may not be one.
Right. What on ARM32? There's no operation that does divrem.
Okay, on PowerPC 6, I'll start naming processors until we get.
So anyway, maybe we are spending too much time on it. I picked up on this instruction because I believe that like the general pattern is valid for many of the instructions that we are talking about. For this one, I really don't see a reason because they will be the same and they are supported on all processors.
I think what I'm trying to get at is that I think it's easier from an engineering standpoint if you say intrinsics are mapped effectively one-to-one, right? So you say you have this method, it's the intrinsic for this CPU, so it either emits this instruction or it fails, right?
I understand that argument.
And then you have the other side of it where it's like, okay, we have general purpose methods where depending on the CPU, we use different intrinsics. And those you code out in C#. You say, if this is supported, call this. Else if, and then you either throw or you have a software fallback. But it's all C# code. Rather than there's some magic component in the JIT that is like 3 pages long, and you have no idea what it does.
And so ARM does not have a combined divide remainder instruction. It only has divide, and you have to compute remainder separately. So there's the perfect example. The two architectures we support, one has an intrinsic, the other doesn't.
Right, sounds good.
The other thing I would assert is it's probably only a few methods that are like that. I think the majority of cases will be more like algorithms that end up using intrinsics, but we're not exposing the particularity of the intrinsics themselves.
The last page. Okay, the last page is really simple, and I think this topic is trivial. That we are missing some incorrect intrinsic overhead, and I think most of them make sense to fix. Yeah, and they are just some design oversight in the first round. Yeah.
And when you say fix, you mean the one with the mistake will be gone because we haven't shipped it, correct?
All right.
Yeah.
Okay.
And then I guess the other question here is, we made the decision last week to just not do generics. There's, I think, for x86, other than static cast, there was 3 or 4 methods. I think broadcast to scalar was one of them, where we currently expose it as a generic. Are we going to make the same decision, just explode them?
And that explosion would be basically we'll have 10 methods, 10 overloads of broadcast scalar to vector 128.
Right.
And they will just take byte star, char star, you know, various integral byte star.
Sure. Yeah. Okay. Yeah, that's all my slides here.
Cool. Okay, and then I guess the big action items for us are, as far as API changes go, is explode the generic methods, fix up SSE 4.2, and move the set all and the other helper methods onto vector 128, vector 64, and vector 256.
Yeah.
Another one was looking at the nested type.
Yeah, the nested type.
Is there a reason we would make pop count return? I mean, I guess we make everything return int.
Oh,
But like pop count can't exceed 64.
yeah. Then for this one, initially we just follow the C++ design, and finally we found that it's inconsistent. Okay.
This is just fixing an inconsistency. I think as long as we pick one, either return int or return uint, and stick with it, it's probably fine.
Fair enough. But I'm looking at like, why would pop count ever return a long? We're being very expressive that this number is 0, 0, 0, 0.
Yeah, in this case we return long because that's what the actual instruction returns. It returns a red 64.
Right.
So Timo, did we cover everything?
I believe so. I'm still typing on the very last slide.
I know you had a list of your own tier, right?
I don't think we did actually. I mean, Tanner might, but
Yeah, I sent it was the list that Imo copied into the email thread.
Oh yes, that's right. Let me open up that guy actually. That good call.
Does a weird question?
Oh yeah, here we go.
.NET div rim and x86 div mod, do they treat negative divisions the same way?
We'll have to check.
Because it's possible we can't rewrite ours in terms of the intrinsic, and that would be a good reason to expose the intrinsic because it gives a different answer.
I believe today the modulus operator compiles down to a div and returns the other half.
But there's always the weird is the remainder allowed to be negative?
Right.
There's a table on Wikipedia, and I don't remember which corner we ended up in and which corner the...
if we're doing modulus or remainder.
Yeah.
You were saying something, Carol?
Carol?
Yeah, sorry, my cursor wasn't moving, so I couldn't unmute. So, I was just saying it would be very surprising if they were different. Pretty sure they were written to use, the existing hardware. So
you're saying we probably were not idiots back in the day. It's a stretch, but
that would be my guess.
Well, like C++ says that the percent operator has no defined answer for when one of the values is negative. That it is up to the compiler to choose. So apparently we match the dividend, and then I don't know what the instruction does.
And Levi said that he liked C++.
I like math. So.
C++, C and C++ really love
being undefined.
Implementation defined behavior.
I was about to say that. Alright, so...
But they can at least change it in the future, as opposed to going with the wrong decision and then...
We can change it in the future. It's probably one of those last famous words in pretty much every language.
Yeah. We cannot even change a comment in object.cs file.
Don't think it's quite that bad yet.
That's pretty close to true, though.
It breaks some software.
If I understand this correctly, then we give the opposite sign that the intrinsic does. Because ours is described as it matches the sign of the dividend, and the instruction says it is less than the divisor in magnitude, which might mean that they use the sign operation from the divisor instead of from the dividend.
We should just look at what the JIT emits, and whatever that is,
yeah,
it's probably correct.
Like we can't change our
answer,
but yeah.
Alright, so now I've arranged a bunch of windows, and hopefully there's a few. Alright, so this is...
That would be a reason for adding unsigned overloads if we don't already have them. But this can use the intrinsic because there's no ambiguity.
No, this guy in here. All right, so these are all the ones that Tanner ended up linking. I think we talked about this one here, so we can probably ignore that one. Is that fair?
Yeah, this was the SSE 421. Yeah.
And then this one we also talked about.
Yeah.
We ignore that one as well.
This was the one that covers static cast in the proposal to just drop one of the generic parameters.
I see. All right.
And we decided to do method on the types instead.
Yep. Actually, let me record that because I'm going to try and type the decision up. This is the problem. Oh, there should be. What's the name? Like as? Is that what we use?
Yeah, I suggested as since that's what we use in unsafe. I think span uses cast instead.
Yeah, what's the thinking of as versus cast? To me, they're kind of implying the same thing. Like
As
two
is-
would be a
as is less
potentially
characteristic
costly operation versus as was meant to be cheap.
I mean, I don't remember the reason we chose cast or span.
I think as never
failed.
fails, right? Versus cast might fail, or was that?
As I said, I don't remember. It would be good to look up. Maybe we have some notes.
I wonder if cast for some people will imply that there may be a cost, whereas as may imply. No, I guess as might imply that there's a cost too, given the C# keyword.
I think cast doesn't imply that much. Cast sounds like it might be something.
Alright, so you can close this one.
Doesn't apply. I mean, doesn't apply to me at least.
Tanner, did we talk about this one?
Yeah, this was the last page. We decided just to expose the methods that where
we just have the vector version, and now we want
I see.
add the pointer.
I think the last page I was paging out.
And the T version will be removed, correct?
Yeah.
We don't support, so do we support doing these operations on kind of structs? Let's say I have a struct with few fields. Do we support vectors over structs like this?
No. You have to explicitly read it as a like vector 1.8 a float, and then operate on that float.
You could do vector of byte and just cast it.
Yeah, you can kind of, through the vector, get the vector of byte and do whatever you want.
Yeah, as long as you can do it.
Alright, we have covered this one. That was the other thing, right?
Yeah.
Yep, and then this one is not familiar. Was it also on the last slide?
Yeah, this was also on the last, I think.
Same, right? This was listed on the last page, I believe.
Yeah, this was normalizing the API.
So I'm just gonna make
So for this one, actually we already solved most of the proposal in this issue.
Yeah. But that was the thing I think we talked about the adding scalar versions effectively. And then I guess it's a scalar as well? Or?
Yeah, this was one of the new API proposals for expose a new instruction.
Sweet. We have covered that one, and then for some reason there's one open on the screen which probably didn't make it over.
Yeah, this is the general.
Oh, that was the original one, yeah. Alright, so then I think we have covered everything. Then I will post the notes. I don't know where I will put them right now. I might put them actually on this one here because that's the only logical place where we have one thing. And then that's it. And the rest will be more or less email based on this.
The only other thing that was on the email thread I sent originally was the combined one for both x86 and ARM. Technically, we already approved the F16C ISA, which allows converting from half to single, but we've not finished reviewing system.half and determining what to do with it.
Yeah, I think system.half is something we should probably talk about more broadly at some point. I would not take all of these things hostage because of that. I mean, that would be not the right way to do it. Sweet. Unless there's any more questions, I think there was nothing on the chat. Let me quickly see, but nope. People were just joking around.
All right. Any good jokes?
Not really.
People, we need better jokes.
Wikipedia says what to say.
All right, guys. See you later then.